Hello and welcome to the trusted Tech Talks Serverless Podcast. This is episode 3. I'm your host, Lloyd Lowson, and today I'm joined by Adrian Hesketh, Calum Dickson and Ben Foster from Infinity Works to discuss serverless. Hi guys, thanks for joining us today, and how are you all?
Hi Lloyd, thanks for having us on.
Yeah,
doing well.
Good. I guess for those who don't know you out there, Adrian, do you want to start off by introducing yourself?
sure. So I'm a principal consultant at Infinity Works, which means I help customers to deliver things, retail websites, financial services systems, healthcare, all sorts of different things. And I guess for the last 4 years, everything I've released has been serverless. I haven't actually switched on a EC2 instance in about that time.
Nice.
Living the dream.
Yeah, Callum, do you want to introduce yourself?
Yeah, absolutely. So my name's Callum. I'm a senior consultant with Infinity Works. Only joined reasonably recently. I came aboard in the middle of the first lockdown, so I've yet to meet any of my colleagues in person. But since then, I've been on one client, and that client has been, I guess, quite early in their transition from a server-full world to a serverless world. So we're first just starting to see the benefits of doing a couple of deliverables in that serverless stack. And in my role before joining Infinity Works, I was a tech lead for a team building a number of serverless backend systems. So I've been able to see, I guess, the end state that we're trying to get this client to, and then a lot of the learnings that we try and bring to clients through our work at Infinity Works. So,
Nice, great. And over to you, Ben.
Cool. So my name's Ben. I'm a principal consultant here at Infinity Works. I've just passed my 4 years with us. I'm kind of similar in what Adrian and Callum are doing. So working with clients to help them build things and fix problems. My involvement with serverless hasn't been as involved as the two of them by the sounds of it. I've not been able to use it in as much commercial angst, but much more of an enthusiast around it, and I can definitely see the merits and the potentials of it. So I've worked with a couple of clients to try and get them onboarded. But yeah, they have challenges which make it very interesting to get involved with.
So what kind of challenges are you talking about there? So I know that you've been a heavy user of Java, haven't you, over the last few years? Has there been sort of angst around cold starts or kind of the way of building applications, or what's been the kind of drivers?
Yeah, so it's kind of been that that encouraging people that serverless is something which is going to be an enabler and a way that they can, and helping them find kind of a path to migrate and transition from systems that they've already got in place to a serverless world. So to put a bit more context of it, I worked with a logistics client of ours for a good couple of years. They were very Java oriented, had a load of microservices that run in AWS, and a lot of them were, there was a lot of opportunities for them to be scaled more efficiently, and some of them to not be running at all most of the time, but just part and parcel of the way that things have been built previously meant that they all followed the same approach of just constantly being run 24/7. So we did start looking at opportunities for them to migrate to a more serverless approach. The challenges that they had were having a very Java-focused engineering team. So it kind of had to still be Java. So there was that. A lot of encouraging people that there were merits to be had in serverless. So from a lot of it, from a costing perspective alone, it just wasn't enough of a influencer for them. The kind of money that they would have saved from moving everything to serverless was kind of pocket change compared to what they're used to. But it also incurred quite a significant development effort alongside that as well. So it's kind of weighing up those, but also showing them that you're not just talking about costs in terms of development effort and time saved on infrastructure. It's all of the other benefits that you get from it. So saving on operations and infrastructure monitoring and management. It's all the security costs that you save by not having to worry about OS patching and all maintenance updates, that sort of stuff. So it is a bit of a challenge trying to convince them that there's a load of benefits to it.
And so you've seen that in other projects, I guess, that you are running around InfinityWorks, right? Like projects which have, I guess, a lower operations cost. I guess the argument is if you've already got an operations team who are kind of busy going around patching, and you have a process that's working pretty well, and it's kind of rinse and repeat, it's the same kind of thing. I guess if you've got things that are working okay, it's harder to make a shift, isn't it, to a new thing, because there's almost an argument of saying, well, actually things are okay as they are, so why bother changing anything?
Yeah, exactly. And I see it as a much more of an enabler for new people who new companies, new innovators and disruptors who want to get products to market quickly, but don't necessarily have all of that backing already in-house. They don't have infrastructure and operations teams, for example. I think it can be really beneficial for companies like that.
I guess there's nothing worse than when you join a place and there's like a million different ways to do things. Every team's got their own little way of running things. Every team's built their own kind of unique CI/CD pipeline. And is that a problem, or do you think that's something to be wary of?
I think it's a consideration. The companies that I've worked for, they've got microservices typically in the dozens. We're not talking about microservice architectures with hundreds and hundreds of microservices, but even so, because they are handling dozens and dozens of microservices built by separate teams, they've all got their own slightly different way of doing things, and then trying to convince them that not only do they want to move over to serverless as well, but they want to kind of unify their deployment approach, and making sure that they're all doing it in the same way kind of has its own challenges as well. A lot of people, when you talk to them about serverless, or at least when I have, they're not quite sure what that looks like from a deployment and management perspective. We've already got, tens of hundreds of microservices. If you're telling us that we now need to break it down into composable functions, how on earth am I going to manage all of that? That sounds like a Herculean effort's needed to do that.
Mm-hmm. I guess the thing there is you're kind of shifting some of the work, aren't you, from your application stack and pushing it into the infrastructure. So, typically you're building you've got a software router on your HTTP router that's taking in HTTP requests. And then either if you're in an MVC type model, it's going to some kind of controller or some class that's responsible for a few different HTTP verbs and actions and that kind of thing. And I guess what you're doing is you're pushing that up into the API gateway generally if you're having a serverless approach. And you're saying that that's a bit of a mind shift for people.
I guess that's where, sorry to jump in, I guess that's where the delineation between development and operations or infrastructure teams starts to break down, because as you're saying, that the full development of the functionality and the control flow can't really be completed in pure code. So you have to build infrastructure to do that. And then, so if you've got a development team that's building the infrastructure, then the idea of handing that infrastructure off to an operations team starts to make less sense, because you've already started to get towards that more full stack, build it, you run it setup. And that's when you get down to, I guess, the question of who owns it in production and who's got that level of responsibility.
So is it that we've hidden the reality? It's like, it's no more complicated. It's just now it's visible in a different layer. So it used to be a server, and now what you're saying is what used to be a server and it was a sort of black box of functions is now very visible as 30 functions in your AWS console. Is that the difference?
I think it's that and a bit of a balance between application code and managed services. I think one of the challenges that I've seen with engineering teams is that you don't just have to learn about your programming language and all of the frameworks that support it now. You now need to know about this myriad of AWS services that help you along the way. So the likes of API gateway, all the other integrations such as SNS, SQS, SES. You could go on listing all the acronyms, and then you've got an engineering team that needs to know about all of this stuff. It can be quite challenging, but at the same time, really beneficial because they are managed services. You don't have to keep writing, and implementing code to manage those cross-cutting concerns for every time. But then you've also got the ability that AWS is going to take care of a lot of that for you.
Ben, your previous project, I know a little bit about them, and as I recall, you were heavy users of RabbitMQ, right?
Yes, indeed. Yeah, we were.
And I've used RabbitMQ a fair bit in the past myself, and you have to know quite a lot about it to use it effectively, right? I mean, so it's not like it's any different, is it? Really, if you're switching to SQS or SNS or others, there's no real difference in the complexity level for the engineer, is there?
I would agree with you on that. I think in particular from RabbitMQ, in order to use it effectively, it is significantly more complex than SNS and SQS and whatever combinations of those two you would use. And I think there's a lot of maintenance and operational overhead that comes with it as well. So for example, anybody who is maintaining a RabbitMQ cluster needs, very deep insight and awareness as to its infrastructure and networking considerations, how it forms its clusters, what you do in the event of a split brain, for example. There's all those sorts of operational concerns that you've got as well. I think the challenge that we've had previously is preconception that RabbitMQ in certain clients is a well-known and understood tool. I think that is sometimes the case. And then the managed service and tool and provided by AWS is a bit more of this kind of like mystical beast that hasn't had enough investigation into it. And I think maybe sometimes it's because it's, somebody else's, it's a managed service. People don't always trust it as much as something that they can physically touch and feel themselves.
There's less levers, isn't there? Or fewer levers, should I say? You can adjust the concurrency, can't you, of your Lambda functions that are pulling from the queue. You can adjust the batch size, and you can adjust the redelivery policy on SQS. But there's not a great deal, if SQS is going too slowly, for some value of too slowly, there's not a great deal you're necessarily going to be able to do. The scaling is ultimately up to the concurrency limits you've put in place on your Lambda functions. Not that I've ever actually had a problem with SQS. It's actually, whereas scaling RabbitMQ is a little bit more tricky, particularly if you want the fault tolerant queues, because essentially you have to write to two machines, don't you, in RabbitMQ? Is that still the case? It's been years since I've used it.
Yeah, still very much the case. If you want high availability queues, you've got to make sure that it's replicated across at least two nodes if you want that level of fault tolerance. But yeah, I've even seen, heaven forbid, in production sometimes where that's not gone particularly well, and you end up restarting part of your cluster and it just wipes out your queue entirely for reasons unknown.
Nice. So I think, isn't that a bit of the tension of serverless, is that ultimately there's this kind of pull towards the managed services of the cloud provider. And I would say, in fact, I kind of like to draw a distinction between the managed services of a cloud provider and the cloud native services. So like, I think of a managed service as being something like the MSK, the managed Kafka. I would say that's like an open source product that's been sort of adopted for use in the cloud by AWS, or the equivalent might be something like RDS, or the relational database service, so running like a MySQL cluster, or let's think of another example, like the MongoDB kind of database, right? It's kind of like they've taken the front end off an open source product, they've bolted it onto an AWS backend, and it's kind of got roughly the same characteristics as the open source product, but it's not the open source product in its truest sense. And then you've got one step beyond that is the things that were made to run on AWS by AWS that are really designed to take best advantage of the cloud. And I think serverless kind of pulls you towards the right-hand side where you're just going more and more serverless. And things like the VPC-based products like Redis and so on just don't really make a lot of sense anymore in that world. But those are the kind of open source products where you can really get into the products and you can tune them, you can really understand them at a deeper level. Whereas I think with the other products, the control is essentially managed by the cloud provider, and that's both the benefit in that you don't have to deal with that stuff yourself, but it's also then, if you're used to having that control, to cede that control requires a huge amount of trust on your part to hand that over.
It does, and that's a conversation I had with a client team recently, because they were a fairly technical data science team. They'd been used to using Apache Spark on their own infrastructure, and we were discussing the benefits of using Amazon Glue versus EMR, and the difference being with Glue, that Amazon does a lot more heavy lifting for you, though. We're definitely still in that managed service category that you mentioned, whereas with EMR you do get access to tune the cluster in a lot more granular way, but then you do have that operations burden. And I think the issue was the team were reluctant to let go of that level of granularity, even though they had no current use case that couldn't be met with Glue. So my angle was, well, we should stick with the serverless option until we have a very good reason not to, rather than engineering for a problem that doesn't exist yet. But it is that trust. They just felt a bit uneasy knowing that if they did get into a pinch, they couldn't reach down into the internals of Glue and really tune that Spark cluster. And I think because they saw themselves as very technical, they wanted to keep a hold of that. It's an interesting tension.
Yeah, I think it's the same tension as as cloud migration before, isn't it? It's the same, exactly the same issue, which is, I can't, tune my hardware, or I can't sort of gain access. I haven't got full control. This feeling of like a loss of control, if you like, of over the infrastructure. But I don't know.
It's similar, I guess, from a security perspective as well. It's that trust factor. We see quite a bit of it in healthcare in particular, where there's a reluctance to go fully cloud, fully serverless, fully managed service, because it's not physical tin that someone can see in a room, and they know that all the patient data is on these rack of servers here. And if something was to go wrong, then I can just unplug the cable, and at least I've got my data secure here and nothing's going to go wrong with it. So there's definitely consideration for things such as, governance and regulatory compliance around all of this as well. So I think sometimes the cloud makes it a bit too easy as well. There still needs to be that level of kind of like pragmatism around how you structure and how you organize all of your infrastructure, where it sits. There's considerations around, what regions you can and can't deploy to based on the kind of data that you're holding. I think
Brexit
considerations. Yeah, exactly. Yeah.
I would never say in my day-to-day life that the cloud makes it too easy. I just can't imagine going, oh, this is just too easy today. That'd be a lovely day. But yeah, there's still a huge amount of configuration to do out there, isn't there? It's like is it about making, accessibility is, I think, what we're talking about, isn't it? So we've got this kind of easy to hand serverless world where we're able to access this stuff quickly, but if we really need control, we can always fall back on EC2, and we can always migrate to classic instances and take more control. But I think Calum's point of, let's start on the minimal viable product and iterate from there. What's the minimal viable product? So it's where we don't have to do anything, and there's just a managed service, and it takes care of most of it, and we can focus on things that are really important, like the code we're trying to run.
Yeah, absolutely. I think that's probably quite a good rule of thumb in terms of when to use serverless. I guess the answer is always, until you find out you can't do something, and then you reevaluate.
Have you found anything you can't do serverless yet, Callum?
I have. In a previous team, we were doing some work with geospatial data, and we had to build these, what was it, something called a geodatabase that captured a certain mapping or geological description of various things. And the open source tooling to build this, we tried our very best to get it to run in a Lambda layer, but it just got limited by the lack of temporary storage. We needed more than half a gig of temporary storage. But interesting, this kind of brings to another point about serverless, in that it's always evolving and being invested in quite heavily by the cloud providers. Because if I was to do that exact same thing now, we could do it in a Lambda, because you can back a Lambda with EBS now, and other innovations in that space. So whilst at the time that wouldn't have been possible, it would be now.
Yeah, it was EFS. It's EFS though, isn't it? Not EBS.
EFS. Sorry, I'm getting my acronyms mixed up.
Very close, but subtly different.
Not quite. That shows how many things there are to learn in this space. But yeah, absolutely. So that was that we had to fall back to doing that in a container at the time, which was very frustrating because it was the only non-serverless thing in our stack. Was this one job that had to run in a container, but it is what it was at the time. Yeah,
there's been a huge amount of innovation over the last few years, hasn't there? That's for sure. Like I know some stuff under NDA, so I've got to be careful about what I'm saying is coming up next.
Same, actually. I had to stop myself there as well. It's so hard, but yeah.
I guess from a company that you kind of, or a client you've worked with, that's been in, for example, like Azure or AWS initially. What makes them, or what makes them want to transition into serverless? What's the sort of, because obviously there's a lot of companies do start out, for example, in Azure, they think that's the right route to go down. But what makes them transition into the serverless side?
I think there's a few reasons. I think it depends on what the use case is. So I think if you think about a kind of traditional web use case, I think the web has changed over the last few years. And probably 7 years ago, I was still writing things like ASP.NET MVC, so server-side rendered HTML. So essentially, you've got HTML being generated by a server and pushed to the user, and then some JavaScript layered on top. So it's kind of, you've got some base markup, and then you've got some JavaScript. And then I think front-end technologies like React and Angular have really kind of taken over there. And I think, so you're now tending to fall back more on those things. And I think in those cases, you're able to, in some cases, create fully static websites. So there's a JavaScript bundle, if you like, that goes to the client, and then that communicates via API. So you might have heard that called Jamstack, where you've got this kind of static website with APIs, and that's been a sort of trend over the last few years. I think that kind of makes you then think about, well, okay, how do I run this stuff? Well, I could just use an S3 bucket and CloudFront, and I've got a website, and then I've got API gateway and Lambda, and I've got everything I need. So, I could put that into a Docker container, and I could sort of do that sort of thing. But I think it just makes it a bit more accessible. I think it makes it simpler to do that sort of thing, because I think it's more similar to what front end engineers have been doing generally. I think that's one reason for it. So I think there's a sort of inexorable technical push to that, and I think the cloud providers have sort of found things that match to that style. I think it's just anything. I think this is always going to be a trend to do less. Like if there's a choice between doing more and less, people are just going to pick the thing that is doing less. And I think serverless means that you do less things or fewer things. And I think so. It's just going to naturally happen over time. I think there'll always be a sort of holdout group who want to do things like they've always done them, and they'll do that for a long time, no doubt. But I think there's plenty of people out there who don't really feel like looking after a server and would like to do as absolutely little as possible to run their services. And I'm definitely one of those people, because there's not a great deal of value in patching servers. It's kind of like a chore. It's like doing the dishes or doing the laundry. It's like, I don't think anyone enjoys it, but you've kind of got to do it. And so if I can get a dishwasher, I'm going to get a dishwasher.
From a business level as well, it makes no sense, right? Because most customers could not care less how a service is built or delivered. They just care that it does what they want it to do, and to a level of security and functionality that they expect. So if you can spend more time on that business logic, on that user-facing functionality, and have your talented engineers focusing on that rather than maintenance that's invisible to the user, then that's all the better for the company. So it's in everyone's best interests.
I'm going to go devil's advocate for a bit here, and so how much maintenance do we actually do, though? How big of a deal is it? Like, there's a cost to it. There's a cost to adopting serverless. We've talked about that. A cost in the sense of if you're doing something one way, there's always like if you're doing something one way and it's working for you, why wouldn't you just stick to it? How much value does there need to be to make you want to shift, to make it worthwhile?
I think that cost is quite invisible, because it's never something that's like amassed at any one point in the project. It's always something that's ongoing, which I think is why it's sometimes difficult to influence people that they want to be going more serverless than serverful. For example, when you've got application stacks where people tend to treat their infrastructure more like pets and a lot less like cattle, it's all the little maintenance bits and pieces that are always ongoing, which I think is what catches people out. So it's like the OS patching, for example. It's like maintaining your Rabbit clusters, even in using a cloud provider and having to build your infrastructure from scratch before you can deploy anything. It's spinning up EC2 instances, for example. It's all the seemingly little things at the time that then amount to the big costs in terms of time and effort.
It's a bit like air resistance. You don't really notice air resistance, do you? But you can feel it.
Yeah, exactly. Yeah.
It's almost easier to see in new projects than existing projects in terms of the time from inception to first value delivered is always going to be greatly increased if you're using a serverful architecture. And if that's true at the start of the project, then presumably that impact on velocity would remain, or at least it would if the project was scaling or growing in any direction.
So you said that it'd be, I think you used the wrong word there, because I think you said it would be faster in a serverful.
Oh, no, sorry, slower. Getting all my words mixed up today. But yeah, definitely in terms of the sheer velocity from a standing start to an MVP with serverless versus traditional stack is hard to deny.
I mean, I'm not, I mean, I think the fight isn't over there, is that in terms of developer usability. So if you look at the new AWS Copilot command line tool, it's taken a sort of opinionated approach of setting up an ECS cluster for you, a container cluster. It creates an elastic container registry. It creates load balancers. It even creates a CI/CD pipeline for you. It's a really brilliant tool. And I feel like the fight isn't quite over there. I don't think, we're still seeing now, I think, improvements. And I think AWS has a long way to go in terms of its usability from a cold start. Like, if you've never used AWS before and you're an organization that's looking to adopt it, there's quite a lot of work to do around control tower and account setup and getting things running in the right way. Whereas if you look at sort of new players like Netlify, Vercel, and others, they're sort of optimizing even more for that kind of early stages of a project where I just want to stand up a website. I want to do a landing page. I want a couple of APIs. I want to get going. And then if I've got a product that works for me, then I might be interested in sort of doing a bit more serious in quotes engineering. But for now, quite happy with just getting a site out.
That's true. I think that's interesting in that is definitely, those are very much serverless offerings, but perhaps not the first ones that spring to mind when you talk about serverless. Maybe your assumption is limited to Lambda, etc., in the major cloud providers, rather than basically anything that is either SaaS or sort of platform as a service that is allowing you, anything in that ecosystem that is allowing you to make those deliverables.
Yeah, Vercel and Netlify actually use AWS Lambda to do their deliverables. But so you could say in some respects, it's like that's how bad using AWS is that there's services that just use AWS, but in a more sort of streamlined way that simplify the process of even having an AWS account. Because I mean, even having an AWS account is a big responsibility because it's quite easy to spend a lot of money by mistake on an AWS account.
Yeah, nice.
Going back to the serverless points, my question is, have you guys ever noticed a situation in where serverless isn't actually the best tool for the job? What I've seen recently is that there's a lot of overlap in terms of AWS's services and what they provide these days. You can have, EC2 instances that are running Docker containers, or you can have Lambdas that now have access to EFS and storage. Is there a time where you wouldn't potentially recommend serverless? And I'm trying to trigger Adrian here because I know he loves it.
I think, like Callum said earlier, it's about serverless first, and then if it doesn't work for some reason, then pivot on that. So I think it's about following the path of least resistance. There are some hard stops on Lambda, right? So one hard stop is the 15-minute execution timeout. The other hard stop is the 3 GB of RAM, and then other hard stops are things like access to specialized hardware. At the moment, you can't access any specialized hardware like a GPU in Lambda. So there are some kind of limits that at the moment would require sort of potentially complicated workarounds. So I think if you're pushing, if if you're finding that what you're doing is feeling like hard work, well, that's counter to my other point, which is just do what's kind of, there's a sort of element of, you need to follow the beaten track, don't you, to a point. In software, I think it helps if you're trying to ship things. It helps not to be the first person to have ever tried to do such a thing before. So I think there's an element of sort of following a well-trodden path, not veering too far away. Yeah, if you're finding it too difficult, then you're probably not doing it right.
I think alongside that, there's always that level of discipline that I think is needed whenever you're trying something out, and just being able to take that step back and realize when there's either a better approach, or whenever you've gone so far that you're having to, you know, put a load of, I guess, band-aids over things just to try and get stuff working. That's always a challenge that I've found.
I mean, I started using Lambda inside of VPC when there was a 10-second penalty for starting up a Lambda in a VPC. So that meant an API call, you know, occasionally would take 10 seconds, which is basically forever. And I thought that the security in that particular project, the security benefits of running Lambda for me, and the reduced hassle I had from dealing with security audits was worth it. So I just decided to wait until AWS did something about it, which they did about a year later. So, you know, I had a year of quite poor latency occasionally, but I got this other benefit, which was, you know, having to do when we're talking to the security auditors, and they're like, well, how do you harden the operating system of your instance? I was able to say, well, I don't, AWS does that for me, and they look after it. You know, what kind of, you know, how do you make sure that you've got the latest runtime running and it's all patched, you know, for your Node.js projects or whatever? I say, oh, I don't do that, AWS does that for me. And so for me in that project, that was the right trade-off, but it's not always the right trade-off, because, you know, projects that I'm working at now, that latency would be completely unacceptable for that use case. So, and I think that's another one actually, is the variable latency. So if you really need really predictable latency, then you're probably not wanting to be in that kind of Lambda world. On the other hand, you know, I've just been working on a project where we've been doing primetime TV advertisements, and it's been great. You know, we handled the Emmerdale Farms spike and the Gogglebox spike and all the other kind of major events. No problem at all. No stress, no hassle, no infrastructure problems whatsoever. And I think that would have been, you know, I know from other, you know, from other teams at InfinityWorks, that those kind of advertising spikes are really can be difficult to deal with, difficult to scale to match those peaks. And you know, it really is fast. You know, it's over in a couple of minutes.
And that's one of the other real benefits of serverless from what I've seen as well. A lot of those situations where you've kind of got like bursty traffic in the nature, you've got to do various levels of capacity planning for it. You've got to predict when it's going to happen and have everything in place ready for it. Like you say there, Adrian, the experience that I've had from serverless is it's reactive, but it's reactive pretty instantly, right? You can spin up as much as you want up until your concurrency limits, if you've got any.
Well, there is a scale limit. There is a scale limit, which I have hit by mistake, which is 500 concurrency per minute. So on a single Lambda function. So if you want to, so if your Lambda function is currently running at 10 concurrent Lambda functions, and you need 510, then you know, it will take you a minute to get any larger concurrency than that, which actually I think is kind of reasonable, because I think I worked it out. I thought it's like, well, that's like spinning up 32 servers or something like that. And I thought, actually, that's kind of reasonable. 32 servers a minute it should be enough for anybody.
Yeah, I guess it's kind of one of those limits which is telling you if you're hitting it, then there's possibly a better way to approach the problem.
Yeah, that's it. My colleagues have done something very foolish there, which is they queued up a bunch of tasks and then let them all go at exactly the same millisecond. And so, of course, you know, tens of thousands of tasks all tried to be processed at exactly the same millisecond. I was like, why don't you just randomize the time? You know, what, do they all have to go at exactly the same millisecond? No. So it's like, okay, well, let's just spread that load out a little bit. There was, you know, I guess if you're not using a system like DynamoDB or other NoSQL database, like I think it's be difficult to scale to meet that kind of throughput anyway. So I think that would have, in a lot of cases, have just trashed a downstream system anyway. It's probably a sensible limit.
I guess going into like, I know you've touched on some areas of the actual cost of using serverless. Is it more expensive to use serverless and introduce that to someone that's not necessarily used it?
I've never seen a team spend more on serverless than a traditional EC2 cluster system. I think generally the costs of serverless are basically negligible, I think is how I describe them. Dealing with kind of clients that are processing millions of prescriptions a month, and they're spending like 50 quid on the compute costs, whereas that would be like 1 or 2 servers. So a fraction of the overall cost, and the cost of non-production environments is much lower as well, because if no one's hitting them, there's no cost being incurred. So I've seen some clients spending like $10,000 a month on a non-production environment that no one's using. That's pretty common out there, believe it or not. And if you strongly adopt the serverless services, so things like DynamoDB, pay-per-request, and Lambda and API gateway, then you're not incurring any cost. So like there's some surprising hidden costs in running infrastructure. So for instance, in a traditional kind of load balancers to web server kind of configuration, even if you've got auto scaling, you're going to have a couple of servers running probably all of the time to make sure that you've got something in each availability zone, as in each data center. And you're going to pay per hour for those load balancers. Even if you've only got 1 or 2 running, you're going to be paying a fixed cost. And then there's some network costs. So typically the best practice as per Amazon is to place your web servers in a private subnet and have a load balancer on the public subnet that's receiving all the traffic. And so you then need a NAT gateway. And I think the NAT gateway minimum cost of that is about $70 a month. And those also need to be fault tolerant. So typically you're going to be spending $100, $150 just to do nothing, basically, before you've even started doing any traffic. And in AWS Lambda in the serverless world, you'll be spending nothing at all. I mean, and that's kind of at the micro end, I guess, of the spectrum. So like that's the kind of like small service that doesn't do very much. But there's a lot of small services out there that don't do very much, and a surprising number where the infrastructure costs are essentially out of line with the value of the service as well. And I think that's interesting, is that there are some services out there where you go, well, hang on a minute, to do this properly, I've really got to be spending I'm going to be spending like $750, $1,000 a month just to run this thing. And you're like, does it give my business $1,000 a month of value? And you're like, it makes it harder to do proof of concepts and kind of speculative things and ideas, things that you're trying out, because suddenly you're spending real money on something that hasn't been proven yet. Whereas I think with the serverless model, you can start off and you can say, well, we've only spent 5 quid. Like, maybe let's give it another couple of months. And, typically the costs are dwarfed by the development costs. The development costs are much higher than the infrastructure costs. So it's the cost of the infrastructure don't seem to be a focus. In fact, most of the time, I'd say that my customers don't really care about the cost of the infrastructure at all. It's just such a small number in comparison to everything else, all the marketing spend, all of the development costs, the risk of being late to market. It's just not in the priority list.
I think there's an interesting impact on the architecture or the possible architecture of these systems based on that cost model, the pay per use model, because there's no cost of ownership of an individual Lambda function or an individual serverless component like a step function. So rather than, I guess, overloading individual components of your system with multiple use cases or multiple reasons to change, thus kind of making them more complicated, but in a traditional sense, saving money, you may as well have as many focused, cohesive parts as you have use cases, so that everything just has exactly one purpose. And that doesn't cost any more than having one Lambda that accepts every single request and then handles them all a little bit differently, because you're only paying for execution. And that, I guess, it really influences the distributed nature that these systems end up looking like.
Yeah, that's a really good point. I used to use a lot of SQL Server, years ago. And when you're paying for SQL Server, you tend to pay for it by, I think it's still the licensing model is, but by CPU core. So you basically want to sweat that SQL Server as much as possible. So typically you've got everything running on the one SQL Server, and the idea of spinning up another one and spending that kind of money again is just abhorrent. You just don't want to spin up another server. So you start putting more than one database on the same database server, and before you know it, you've got like 15 databases running on the one box, which is fine up until somebody uses up all the resources of that one box. And like that, for that 1 hour of a week, the huge reporting load just smashes down and trashes the transactional throughput of your system, and you get all these kind of complexities around that. And I think it's the same with the web server that's got a million things running on it. It's all fine up until it breaks down one day because there's a really noisy, there's a marketing push on one side of the business, and it just happens to coincide with another important part. And before you know it, you've kind of overloaded a server, and everybody's suffering. So it makes it harder to deal with issues and problems, because things are grouped together in order to save costs on licensing and infrastructure, rather than separating them as you'd really like them to be separated. So yeah, no one cares about costs, Lloyd. No one cares.
Right, fair enough.
The numbers aren't big enough. To put, should we put those into perspective then of what we mean by not big enough? So I think, like a pharmacy system running with over a million prescriptions a month, running an online pharmacy and all the rest of it, about $5,000 a month max. So not huge numbers in the grand scheme of things. And for that, you're getting a fault tolerant system. You're not running your own data centers, they're running those for you. You've got multiple data centers distributed around the UK for free. Huge amount of value, I think, for that kind of money.